So we spent a couple of days, a few days actually, looking at tables and looking at patterns in tables. A couple of days on trying to develop the rule when you're given the pattern of numbers, and then a day on looking at what the pattern tells us about the type of relationship. And we looked at linear relationships compared to non-linear relationships, right? And again, in grade 9, we're looking at linear relationships, which is really nice because linear relationships boil down to those two most important things. What are those two most important things? That's what I'm going to ask that almost every day for this whole unit. And I want you to be able to answer that question. So every day I ask that question, I want you to think about the answer and try to come up with it yourself. So what are the two most important things about a linear relation? Where it starts and what's the change, right? And it all comes down to whether you're given the numbers, so in a table, something like that, or you're given the rule, or you're given the graph. It all comes down to how can I figure out those two important details. And there are questions that are more complicated than others. There are simple ones and ones that are a bit more challenging, and we'll get to those. But still, you can boil it down to the same thing. I have to find two things. I have to find where it starts, or how much for 0, and I have to find what's the change. Okay, so what today is about, like I said, we spent a few days looking at the pattern from tables. So what today is about is converting between all the different forms. So what if you start with the rule? Okay, then you have to find the table and the graph. What if you start with the table? We've done a lot of that already, but we're going to do it again today. From the table, can you come up with the rule and the graph? And what if you start with the graph? Can you come up with the rule and the table given the graph? And like other times, there are lots of strategies that you can use for this. And we'll talk about some of the strategies. Some of them we might not be able to get to. And in that case, it'll be up to you to work through the practice and see if you can come up with some ideas that work well for you. Okay. So we started, all the other questions we looked at, we were generally given the table. And like I said, we are going to do one of those today, but we're starting with one. I can see that I've got a space for the rule, a space for the table, and a space for the graph. My first thing is to determine what are we given, and it sure looks like we're given the rule in this case, okay? And I'm just going to write that down. So we're given the rule for this question, okay? And from the rule, we have to come up with those two important things. Where does it start and what is the change? And what is the trick that we learned before? We learned that the change is the number that's multiplied by the x, and the start is the number that's all by itself. And even if I wrote this the other way that we've often seen these, 4 plus 3x. So this is written backwards compared to the first one, but it means the same thing. And the start is still the 4, and the change is still the 3. So it doesn't matter what order they're in. What matters in is which one is beside the x and which one is not beside the x. That's how we determine what the change is compared to what the start is. Now, once you have figured that out, no matter what you're starting with, whether it's the rule, the table, or the graph, once you've figured that out, you can do the rest of it in whatever order you want. You can go straight to the table, you can go to the graph, you can do what you like. And in some cases, again, it might be easier than others. This one's fairly straightforward. We can see that the table has the 0 in it. That's the start. So if my start is 4, I can put that right in there. And what does it mean by the change being 3? That means I'm going up 3 every time because it's a plus 3, right? Or if I'm looking at it here, it's a positive 3. If it was a negative 3, I'd be going down. It's a positive 3, so I'm going up. So 4 plus 3 is 7. 7 plus 3 is 10. Remember, the other thing we did was we talked about using the rule to find a value directly. I don't have to do that in this case because I can just follow the pattern, but it's something we might do down the road. So if I wanted to do that in this case, I take, I'm going to do that in a different color. I take this 4, okay, and I put it in the brackets for x, because that's my x value, and then I evaluate it. 3 times 4 is 12. 12 plus 4 is 16. You can use your calculator for that. You can just do 3 times 4, 3 bracket 4, plus 4, right? And do it all straight away in one shot, whatever works for you. But this one works out to 16. Oops. And if I followed the pattern, it'd be 4, up 3 is 7, up 3 is 10, up 3 is 13, up 3 more is 16. So it works both ways, okay? So we don't have to do this in this case, but like I said, it's something we're going to do down the road. So it's nice to see it ahead of time and start getting familiar with it, because the first time you see something is the hardest to follow. But if you see it kind of every day for the time being, even though we don't need to do it, by the time we do need to do it down the road, you'll already have seen it a bunch of times, and hopefully that'll make it easier. Now I can turn this into a graph, and again, there's 2 ways to do it. I could take all of these points. I could think of them all as points, and this is why we plotted points on the very first day. I could turn all of these into points, the x and the y. Oops. Okay, that's one way, and just plot these points. And in fact, I'm going to plot one of them right now. I'm going to go over 4 and up 16. Or I could use the start and the change. So I'm starting at 4, and every time I go over 1, so I'm going over 1, I go up 3. So from here I go 1, 2, 3. Over 1, up 1, 2, 3. Over 1, up 1, 2, 3. And take a look at this, over 1, up 1, 2, 3, which is where we thought we were going to be just by plotting that point right there. Okay. And again, now we don't just leave them as dots, and we're not playing the game connect the dots here. We are drawing a line all the way through them, up past the end of the graph, extend it even further past the graph, right? And so I started with the rule, we were able to come up with the table and come up with the graph. So that's one of the sort of 3 kinds of questions that we're going to get today. Question B is very familiar, because this is the one where we are given, or starting with the graph, the table, given the table. Okay, we're given the values in the table. So as I said, we've already done lots of this, and we're looking for the start and we're looking for the change. And you don't have to write them out like this. I'm doing this because I think it's clear for the lesson. It's not a bad strategy to organize your thinking by doing this. My start is how much for 0, so that's 12. And what's my change? Well, I got to do some work for that. So I'm going to look here. That's down 2. I subtracted 2. 12 to 10 is down 2, so minus 2. 10 to 8 is minus 2. 8 to 6 is minus 2. 6 to 4 is minus 2. Okay, so my change is minus 2 because I went down 2 every time. That's a minus 2. And so I can write this 2 different ways. I can have the start, and then every time I'm subtracting 2 times x, and don't forget how to write that. It's really important that we get used to and that we're practicing writing these rules or equations. We also call them equations, writing these the correct way. Okay, but I always multiply the change by that other variable, the x. Or you could write this as y equals negative 2x plus 12. So notice the signs here, that the negative 2 is still a negative 2, right? And this was a positive 12, and it's still a positive 12, okay? And some people might have done it like this, y equals 2x minus 12, because they think the minus sign is between them, so it stays between them. But that's not how math works. The sign of something goes with the something that it starts with. It stays with that number always, always, always. It doesn't flip to another number. Okay, so I've got my rule written out, and now I can turn this into a graph. And this one will, lots of ways I can think about this. I can think about, like we did in the last one, I've got these points, so I can just plot those points, and 0, 12 would be this point here. Or I can think about the start and the change. I'm going down 2 every time, and at 1 I'm at 10. So if at 1 I'm at 10, well, look at that. It's going down. When I go over, I'm going down. Over 1, down 2, over 1, down 2. Okay. And this is, in some ways, for a lot of people, probably the nicest way to look at it. Anybody who's quite visual is going to like looking at it this way, because you can see that it's going down. We're starting here, and I'm going downwards, right? But it's important to connect that to this idea that I'm also going down in the numbers. My change is negative. My change here is negative. Like, I'm connecting all those different ideas with the visual of that line actually going down. Okay, again, we've done lots like that, but today is really neat to compare all the different ways that we can start, given the rule, given the table, given the graph, and how we can go to the other two. And it's really important to be versatile and be able to do all of them. Last example here is the one where we are given the graph, okay? And sometimes the graphs are a little bit easier because it even gives you points. This one doesn't. So I have to follow this line, and I have to see where the nice points are. And this one's easy. And for now, I think they're going to be fairly straightforward, but it will come a time where it's not as obvious. And so we'll start talking about it now. A point has to be a perfect point. So I can see that in this space here, the line goes right through where the grid lines meet, okay? It hits that point there exactly. And that means it's a point. If it misses by even a little bit, it's not a point. We can't round. That'll really wreck stuff. So here's one strategy. I could take these points and put them into the table. Why would I do that? Well, because I'm a lot more used to using the table. We've used the table for days now. It's something we're comfortable with. And so if I take these numbers, so for example, this is 3, 1, 2, 3. So that's my x. And at 3, I'm at 6. Okay, so there we go. I can just fill that in. And once I get the table filled in, I can use the table to come up with the rule. So that's a totally fine strategy. I recommend you use it. It's the easiest one for us right now because we are comfortable using that table because we've already done it lots of times. But I'm also going to, it is something that we're going to have to do eventually, is be able to come up with the start and the rule, or sorry, the start and the change from the graph to come up with the rule a bit more directly, okay? So let's start thinking about that. Let's start looking at that. And then again, down the road, that's something we'll be able to do. Well, the start is where it starts. It's where it crosses this dark line. Remember, we call that the y-axis because it's y. If it was something else, we would call it the other axis, but it's the vertical axis. And it's where does the line cross through there. And if I go up to the other examples, at 0, I was at 12. And notice that point on the vertical axis is at 12. And same thing up here, I started at 4, and that first point there is at 4. Okay, so when I look at this, my first point is at 0, so that's the start, or that's how much for 0, it's 0, and I can enter that in. And then I'm going to ask, well, if I go over 1, how much do I go up? Okay, and I went over 1, I went up 2. I'm going to do it in a different color here. Okay, and I go from here, I go over another 1, and I go up again 2 plus 2. And from here, I go over another 1, and I go up 2 again. So my change is 2. So my start is 0 and my change is plus 2. And being able to write that out is a really good first start. And then I can turn that into my equation and I can turn that into my table, hopefully from there. You don't have to go straight to the table. If you want, you could just focus on figuring out the start and the change first. And then the next step is, how do I put that into the table? How do I turn that into my equation or my rule, right? And if I start at 0 and I'm going up 2 every time, that's going to be 2, up 2 more is 4, up 2 more is 6 that we already got, and then up 2 more is 8. And again, 4 and 8 is one of those points. Okay, so I've got that. And I've already got the start and the change, so this is y equals my start, which is 0 plus 2 times x, or y equals 2x plus 0, or we've talked about this before, I really don't need that 0, so I can just call it y equals 2x. But any of those three is fine. You're going to get full marks for that. It's totally fine. Eventually we'll get used to not having to write the 0, but if you like it for now, absolutely, by all means, leave it in there. Okay. And so that's that. So we've done one of each, starting with the rule or the equation. That was A. Okay. And coming up with the table and the graph. B was starting with the table, the one we've done lots of already, coming up with the rule or the equation and coming up with the graph. And then C was something new as well, starting with the graph and from the graph coming up with the table and the equation. And those are the three things that today we're focusing on. I've said this before, there is a fourth and it's coming in a few more days, but we're not there yet. And then those are the 4 ways that we represent. That will eventually get us to the 4 ways that we represent linear relations, okay? That's about it. I hope that is clear. There's some practice for you to do. There is one more section for another example here in the lesson. And what's the point of this? Well, you'll notice all 3 are blank. And so I would encourage you to come up with your own. And whether you start with the rule or the table or the graph is entirely up to you. If you start with the table, make sure that your change is consistent. Okay, don't go 1, 2, 4, 8, 16, because that's not a linear relation. That's doubling every time. That's something else. So just make sure that you have a consistent change. And if you start with the table and put it into the graph and don't get a straight line, then you're going to have to go back. It would be fine to graph something that's not straight, but coming up with the rule for that is something that's going to be trickier for us, because that's not really something we've talked about at all. And that actually is quite a bit trickier when it's not a straight line. So you could start with the rule, or you could start with the table, or you could start with the graph. And if you start with the graph, just make sure you get a nice straight line that goes through a bunch of the grid lines, okay? And if it doesn't work, you can either stop and move on to the practice, or you can try again and start with something else. If you start with the graph and it's not working, then move over to the equation. Eventually, again, this is another activity we may revisit where it's a bit more open and you can kind of start where you want, or you can make a question for a friend, something like that. But for now, if you want to give that a shot, that's fine. Otherwise, you can take a look at the practice, which will be more of starting with one of the 3 different representations of a linear relation straight line that we have and turning it into the other 2.